Hello all. The topic of presentation is design and simulation of common source amplifier. In last practical we have designed the voltage divider bias circuit using MOSFET. Now in this session we will discuss about the common source amplifier and measurement of voltage gain, measurement of input resistance and measurement of output resistance of common source amplifier. From experiment number 1, that is DC biasing of MOSFET, we have simulated and we have got the values of ID is equal to 16 milliampere, VDS is equal to 5.01 volt and VGS is equal to 2.56 volt. We'll assume the coupling capacitor value 10 microfarad and bypass capacitor value will be 100 microfarad. By using the rules, we will able to calculate the input impedance theoretically, and theoretically the input impedance is 66.67, that is 200k parallel 100k. The output impedance R0 is equal to RD, which is equal to 470 ohm, and the transconductance, that is GM, is calculated as 2 under root k into ID. We'll put the value of k is equal to 50 into 10 raised to minus 3. This value we have got from the data sheet of 2N7000, and ID is equal to 16 milliampere, and that's why we get the value of GM is equal to 56.57 milliampere per volt. AV, that is voltage gain, is calculated as minus GM into RD, where minus sign indicates that it is a common source amplifier, that is output and input are out of phase, and hence the voltage gain is minus 26.59 volt. Now we will measure the voltage gain. The procedure for measurement of voltage gain is like: build a circuit on the breadboard, apply VDD is equal to 16 volt as shown in the circuit diagram, apply 100 millivolt peak to peak 1 kilohertz of input as a sine wave to the coupling capacitor C in, measure the output voltage, and the gain is calculated as AV is equal to V0 by V in. So if we simulate this circuit, we have got V0 is equal to 2.67 volt. At the input, V in is equal to 100 millivolt peak to peak, and that's why gain is equal to V0 by V in, that is output voltage divided by input voltage, which is equal to 26.70. Gain is a unitless quantity. Measurement of input resistance: connect 100 kilo ohm resistance in series with the input capacitor, that is C in, then measure the output voltage, that will be V0 dash, and from the formula calculate the input resistance. So here we connect the 100 kilo ohm resistance in series with the function generator input and coupling capacitor and measure the output voltage. The output voltage is V0 dash, which is equal to 1.07 volt. And if you put the value of V0 dash in the formula for calculation of input resistance, we will get Ri is equal to 66.88 K. Next we will calculate the output resistance. So connect 1 kilo ohm resistance between output capacitor C0 and ground, measure the output voltage, that will be V0 dash, and calculate the output resistance using the formula for R0. Before that you have to remove the resistance which is connected between coupling capacitor and function generator input. So for calculation of output resistance, connect 1K resistance across the output and measure the output voltage V0 double dash, that will be 1.81 volt. Now if you put the value of output voltage V0 dash double dash is equal to 1.81 volt, you will get R0 is equal to 322 ohm. If we compare the results with theoretical value and simulated value, we will get AV theoretically we calculated at 26.59, and by simulation we have got 26.70. Input impedance theoretically it is 66.67, and by simulation we have got 66.88 K. R0 0.470 kilo ohm, whereas by simulation we have got 0.322 kilo ohm. So this is how we have validate our theoretical values with the simulation values. Thank you.